Hi, today I'm talking about LeetCode problem 478, generating random point in a circle. What this problem asks you to do is write a solution object such that the constructor or initialization method takes a radius, an x and y center point, and the solution object should provide this function randPoint, which when called will return a random point within the circle described by the radius and x and y center coordinates. In other words, if we have an x and y center coordinate and a radius of r, we can imagine that that radius draws out a circle around x and y. And randPoint should return for us a uniformly distributed random point within this circle. So uniformly distributed just means that any point within this circle or on its circumference is as likely as any other point within this circle. So you may think that a possible way to do it is just to imagine the circle as a little spinner. And so you could just imagine spinning a little spinner along here and letting it land wherever it may lie, and then picking a point along the length of the spinner. So you could just pick a random angle for the spinner to spin to, and then you could just pick a random distance along that angle and draw a point there. But one problem with that is that the points would be more sparse the further out you go. So if the points are equally likely to land at any point along this spinner or along the radius, then the points are going to be pretty spread out towards the edge of the circle, and they'll be very tightly packed together towards the center of the circle. In other words, it won't be uniformly distributed, which is one of the requirements. So there is a mathematical or analytic solution for this problem, but when I was thinking about it, I wasn't able to come up with what the analytic solution is. After I submitted the problem, I read the discussion section and saw that other people did have the mathematical and analytic solution, but I wasn't able to come up with it by thinking about it. Instead, what I came up with is an alternate approach where I took the radius, the center point and the radius. And I imagined that instead of describing a circle, I just asked myself, what about a square that kind of bounds the circle that I need to be returning a random point within? So if I had drawn that better, you would have seen that the square is just bigger than the circle, but the circle is contained within it. So I asked myself, how could I get the square for this circle? And yeah, I'll just explain briefly how I did that. So I considered the square would be between the 0 point of the square, or the square's origin, and the end point of the square. And to get to the 0 point from the center, you just go up 1 radius and then left 1 radius. So like add a radius to y, subtract radius from x, and you're at the 0 point. And then to go from the 0 point to the end, it's just plus 2 radiuses to x and minus 2 radiuses to y. And then we have our, the bounding box for this circle, a box that goes all the way around it. And so then I just want to pick a random point within my square. And some of those random points will be inside of the circle, and some of them will be outside of the circle. But if I pick just random numbers, like a random x between the 0 point and the end x, and a random y between the 0 point for y, and the end point for y, I'll have a uniformly distributed point. The only problem is that maybe it's within the circle and maybe it's not. So how we tell if a point is within the circle or not is if the distance between a random point is greater than the radius, then we know it's outside of the circle. And if it's less than the radius, we know it's within the circle, less than or equal to the radius. So you can calculate the distance between 2 points in a Cartesian plane using this formula, which is x2 less x1 squared plus y2 less y1 squared. And that whole quantity raised to the half power, or another way of saying that would be the square root of that whole quantity. So that will just tell you the distance between 2 points. So if the distance between those 2 points is less than or equal to the radius, it's within the circle. If the distance between the 2 points is greater than the radius, it's outside of the circle. So ultimately, I guess this is the square point function. It's pretty straightforward. It's just a uniformly random point starting at the x0 point, ending at the x end to give me my random x coordinate. Same thing for the random y coordinate. And then the ultimate function, which will solve this problem, is the rand point function. And what it does is it starts with a random square point. So remember that this square point may be within or outside of my circle. And it's just going to say, while the point distance between my random square point and the center point of the circle is greater than the radius, pick a new random square point. So this may require any number of random square points, but in practice, it picks a circle point pretty quickly. As you can see, the circle is most of the area inside of the square. So it won't take us that long to find a random one inside of the circle. Yep, so that's pretty much it for the solution. As I mentioned, there's a mathematical or analytic solution, and that, as you might expect, is much faster than having to pick random points until you get one that happens to be within the circle. But I think I was at least pleased that I was able to solve this problem in code, even though I wasn't able to solve it by mathematically analyzing it. And I guess, to be honest, I wonder how many of the people who were able to solve it solved it by kind of Googling for that question. Which, that's fair, however you want to use LeetCode. But I like to think of myself as having done a pretty good job in that I found my own solution without having to Google for what it was. Who knows, maybe other people were able to find the mathematical solution easier. I shouldn't disparage them. Anyway, I intend to try to get a LeetCode problem a day or something like that cadence. And as soon as I finish a LeetCode problem, I just want to record myself explaining what it was and how I solved it, and then share that on YouTube. So if that's the kind of thing you're interested in, let me know. Click the like button, subscribe to the channel, say something in the comments. Anything's appreciated. Thank you very much.